This video is a continuation of the functions notebook, and we're going to be discussing function arguments.
So we've seen many examples where we pass a value, an argument, to a function via its parameter list. When we pass an argument, meaning when we pass a value to the function, we're doing so by reference. That is, the function is receiving a reference to the original value and not a copy of that value. What this means is that if we pass a mutable object, like a list, any changes made to that mutable object by the function will be visible by the caller of that function. So as an example, let's say we have the list containing 1, 2, and 3. And we define a function foo that appends the value 4 to the list passed as an argument. Now let's print out our original list. Then we'll call our function foo, passing a list as an argument. And then we're going to print out the list again after foo. Now when we run this block, we see that before foo was called, we printed the list containing 1, 2, and 3. And after the function foo, we printed the same list, but now it contains the values 1, 2, 3, and 4. Notice that foo did not return the list, and we did not rebind our variable a list. In fact, foo did return none since there was no explicit return statement, and we see the modification to the list because Python uses pass by reference. Okay, so let's do this again, but this time let's use a string, which is an immutable type. So we'll start with a string containing 1, 2, and 3. And we're going to define the function bar, which takes the string s and is going to append the string containing 4. And then we're going to print as we did before. We'll print the original string, call our function bar, and then print the string again. And when we run this, notice that the output before and after the call to bar is the same, meaning that even though Python is passed by reference, we do not see the character 4, which was appended to our string inside the function bar. So why is that? If you recall from our discussion of strings, strings are immutable, as we said, which means that when we want to append a character to a string, we must create a new string that contains all the characters from the inputs. And when the compound assignment operator plus equals is used, it's creating that new string and then rebinding it to the variable name on the left. Now, when we bind names within a function, the name is local to that function and is not visible outside. So our variable a string still points to the original string even after the variable name s inside the function was rebound to the new string object. And this is the reason we don't see that change outside of the function. Now we're going to have more to say on this when we get to name resolution and scoping rules in later sections. Okay, when we define a function, we may wish to provide some default arguments for certain parameters. By doing so, the caller of the function can actually omit those arguments when calling the function. And if necessary, they can override those arguments by passing different values. So this is more easily understood if we walk through an example. The following function prompts the user for yes or no input and returns true if the user entered a valid yes response, false if the user entered a valid no response, and none if the user failed to enter yes or no in some number of tries. So if we look at the parameter list here, the first parameter is the prompt, which is the yes/no question that is to be posed to the user. This parameter has no default, and therefore it is required to be provided in every call to ask OK. The second parameter, retries, is the maximum number of retries that will be given to a user for a valid yes/no response. The default here is 4, and is defined by following the parameter with an equals and then the default value for that parameter. The last parameter, reminder, is a string that will be displayed to the user when they fail to enter a valid yes/no response. And this parameter has the default string, please try again. So even though this function takes 3 parameters, we can call it by passing only the value for prompt and use the default values for the remaining 2 arguments. And when we run this, you'll see that it poses our question, do you really want to quit? And then it presents a prompt and waits for our input. If I provide something other than what is specified in the tuples above in the function, then it's going to ask me to please try again using the default value for reminder. So if I put capital Y here and hit enter, you'll see that it asks me to please try again using the default value for the reminder. Capital Y doesn't work here because it doesn't match any of the valid strings in the 2 tuples specified in the function above, namely y, ye, and yes for the positive answers, and n, no, nop, and nope for the negative answers. Recall here that upper and lowercase characters are different characters, and so the in operator here would actually fail to find an exact match. Hence the reason we were asked to please try again. So if I enter lowercase y, you'll see that this does work. It returns true, and the function returns. Now, let's say that we didn't want to have 4 retries, as is the default. We could override that behavior by specifying a value for retries. So say we want to give the user only 1 additional attempt to answer the question. So if I write ask OK, and I want my prompt to be OK to overwrite the file, I say comma 1. And now when we run this block, you see it gives us the prompt again. If I again give an incorrect response, say capital N this time, and hit enter, it asks me to please try again. And if I hit capital N one more time, you see that it tells me I have an invalid user response, having given me only 1 chance to retry to answer the question. And of course, we can override all the defaults by providing arguments for every parameter. And if we run this, you'll see that if I enter an invalid response, the reminder has been updated to our new string here. And if I enter a valid response, once again, the function exits. Now, in addition to using and being able to override default values, you may have noticed that the order in which the arguments were given matched the declaration of the parameters in the function definition. These arguments are referred to as positional arguments, and is also the reason why default arguments tend to appear after the mandatory arguments, which in this case was only the prompt parameter. In fact, it's a good practice to order the parameters such that the most commonly set or changed arguments appear first in the list. Now, you may have noticed in the previous example, we used constant literals as our default values. You can actually use variables to define defaults as well, but the default value is assigned only once when a function is defined, meaning that if a variable used to set a default is rebound after it was used to define that default, then the rebinding does not affect the default value. So let's look at an example. Let's create the name I and bind it to the integer 5. And then we're going to write a function, myPrint, which takes a single argument, whose default will be I, and then it just prints that argument. Now, before we call our function, let's change the value of I, and then call our myPrint function using the default, and then actually let's call it again with the value 2, and then once again with the default. The output here shows 5, 2, and 5. The first 5 is printed by the first call to myPrint, which used the default value. Now notice that the default value is I, but I currently had the value of 6. And the reason for this is that the default value was set when the function was defined. And at the time the interpreter read and evaluated the function definition, the variable I had the value 5. The second call to myPrint was passed the value 2, which was output as we expected. Right? The value 2 overrode the default value and was printed. And then the last call used the default again, which is still 5, just as before. Now, integers are immutable. And so when we rebound the value of I, you see that it did not affect the default value that was set in our function myPrint. But what happens if we try to use a mutable object as a default? So we're going to write the function myAppend, which is going to take a value A, and we'll append that value to the list L. Now, if no list is given, it will use a default value, which is an empty list. After the value is appended, the function simply returns the list L. So with that function, we're going to now call myAppend with the value 1, and we're going to print its output, right? So myAppend returns a list, and we're going to print that list. And since we did not pass a value for L, the default empty list was used, and the value 1 was appended to it. This looks fine. Let's call the same function again on the next block. So what happened here? In the output, we see that the value 1 is still present in our list, even though we did not pass that as an argument to the function myAppend. So the default value here has somehow been modified by our previous call. It turns out that because lists are mutable, the in-place modification of the list actually changed the object that the default value pointed to. So when we ran myAppend with the value 2, it used the same list as the previous call. And if we do this again, you'll see that it modifies the default list yet again. So we see that every call to myAppend without specifying L will modify the default list. And this happens because we're not changing the list object that's specified as a default. That object is still the same object. What we're really doing is appending to that same object. And so one way to avoid this problem is to use none in place of the empty list as a default. And then inside the function, we'll actually check to see if L is none. And only if it's none do we then create a new empty list to serve as a default value. So by doing it this way, if we were to repeat the previous calls to myappend, you'll see that now each list that's returned by myappend contains only a single element that was actually specified. And each call to the function created a new empty list to serve as the default. Up until this point, we have been using positional arguments, meaning that we're giving the values to a function unnamed and in the order that they're specified in the parameter list. We can also use what's called keyword arguments, which allow us to specify the parameter name with the value. And in so doing, we can actually specify these in any order we choose. So consider the next block. The print args function simply prints out the arguments passed to the function. The first parameter, voltage, is mandatory as it does not have a default value, while the remaining parameters all have a default specified. The calls that follow here are some of the ways that this function can be called. Notice that in the second line here, we're specifying the parameter for voltage, followed by an equal sign and then its value. This is an example of using a keyword argument. Now, I'm going to let you look through these and tinker with the remaining calls here, but I'll point out here in the fourth line that the action parameter is given before voltage. And so this is an example where we're using keyword arguments allows us to change the order in which parameters are specified. And when you run this, you'll see that this example still prints out the correct values for each of these arguments. Also, I want to point out that if you're using keyword arguments, you can only use each parameter once, regardless of whether you specify it using positional and keyword, or through multiple instances of the same keyword argument. For example, the following function takes only one parameter, and if we attempt to pass a positional argument followed by a keyword for the same argument, you see that we get a type error exception raised stating that multiple values for A were received.